In this video, we're going to be writing some equations of some linear functions, and we're going to finish it up in slope-intercept form. But the way that the information is going to be given to us is going to be in function notation and then in an application problem. Let's get started. So in part A, we have write a linear function f with the values f of -3 equals -1 and f of -2 equals 4. So it looks really confusing, but all it's really saying is that this is y, and this is the value of y. So this is the value of y when x, value of y, when x is -3. So when x is -3. So it's just giving it to you as an ordered pair, really. So this other ordered pair over here is going to be a -2, 4. And now that we have 2 points, we can find the slope of our equation by using the slope equation. So remember that slope is going to be our y2 minus our y1 over our x2 minus our x1. So let's go ahead and label. Here we have x1, and here's x2, and then here is y1 and y2. Let's go ahead and let's replace our values. So our y2 value is a 4, and our y1 value is a -1. Let's go ahead and let's replace our x values. So we have an x value of -2 and an x1 value of -3. And when we see this, we're like, oh, those double negatives and double negatives. So we can solve this, and we're going to get 5 over 1. So here we're going to have a slope of 5. And because we have the slope and a set of points, we can use point-slope form, which is y minus y1 equals m times x minus x1. Well, we have a y1 and an x1, and we have an m, so we can go ahead and we can replace those. So we have a y1 value of -1. We have an m value of 5. And we have an x1 value of -3. And we're going to need to simplify this a little bit because we have some double negatives. So this is going to give us y plus 1 equals 5 times x plus 3. Our next step will be to distribute our 5, which is going to give us y plus 1 equals 5x plus 15. Then we're going to subtract 1 from each side so that we get the y by itself, and that's going to give us y equals 5x plus 14. And we're finished. So here we have our answer in slope-intercept form. Let's give letter B a try. So here it tells us that Craig is driving at a constant speed of 60 miles an hour. And after driving 3 hours, his odometer reads 265 miles. So we're going to write a linear function, and we're going to call it D, that represents the miles driven after h hours. And what does the odometer read after 7 hours of continuous driving? So I actually want to pause for a second and go back up to letter A, because we're not actually all the way done. It asks us to write it as a linear function of f, which means that this is not good enough. It needs to be written as an f of x. So it'll be f of x equals 5x plus 14. That's how you write a linear function. Now we're finished. So we're going to need to be careful because it asks us to do the same thing here in part B. So we just want to make sure that we finish it correctly. So remember that slope is also our rate of change. And we see that we have a rate of change of 60 miles an hour. So that tells us that our slope is 60 miles an hour. It also tells us that after driving for 3 hours, the odometer reads 265 miles. So that's a point in time. So we're able to say that after 3 hours, we've traveled 650 miles. And so we have an x1 value and we have a y1 value. So we have a point and we have the slope. So we want to use the point slope formula here. So remember that point slope formula is y minus y1 equals m times x minus x1. Now we know what our y1 value is, so we can replace that. We have a y1 value of 265. Let's scoot that over. There we go. And we have a slope value at 60. Our x1 value is at 3. And it looks like we don't have any double negatives to simplify out, so we have y minus 265 equals 60 times x minus 3. So we'll distribute our 60, which is going to give us y minus 265 equals 60x minus 180. Then we'll add 265 to both sides, which is going to equal 85. So now we've got our function. We want to make sure we write it the right way. And look at what it's asking us to use. It's asking us to use h instead of x. So we're going to take out our h, or x rather, and we're going to put in the h. So we're putting h there. Remember, because it asked us to do that. And it also asked us not to call it y. It wanted us to call it d for distance. So d of h for hours, right? So d of h. And so this is our equation. That's our linear function. And then it asks us, what does the odometer read after 7 hours of driving? So remember, our 7 hours of driving represents, so our 7 hours represents our x value, right? Or in this case, our h value. So we're going to plug that in. So we want to know, what is d of 7? So 60 times h plus 85, and this is where we'll plug our 7 in. So if we take our calculator and we take 60 times 7 plus 85, then we should see that the distance after 7 hours is 505 miles. So that's going to represent our second answer because it asked us to do two things.